there, eighth graders. This is week number 11 of e-learning. Last week ended the first marking quarter, and I had given you a little lab activity to do. And what you were doing is you were creating some molecules from some gumdrop atoms that are elements, atoms and elements that I had sent home middle of last week. Now, this isn't due until this week, and it's going into the second marking quarter. So, I've got my lovely assistant with me here on this fine Saturday night. This is what the Johnsons do on a Saturday night in their house. Emma is going to help us put these models together, and these are the kind of models that you may or may not have gotten to yet. If you haven't gotten to them, well, maybe go get your stuff and you can work on putting yours together. So Emma, right now, while I continue talking, I'm going to ask you to first build a water molecule for the students to see, and then I want you to build a molecule of carbon dioxide. Okay? Go ahead and get started. All right, here she goes. She is starting by making the water molecule right over here. All right, Emma, making this water molecule. Right here, the water molecule. Hold it up. Hold it up for them to see. Okay, you ready? I'm going to ask you some questions.
Yeah.
Okay, starting with, why did you choose the colors that you chose?
Because it's the same ones as the diagram.
Ah, okay. So she chose the red and white because that's what she had access to. In the event that you got gumdrops home that weren't red and white, well, it doesn't matter. You could have used two other colors because, take a guess, why do you think there's two different colored gumdrops?
Because there's two different elements.
Yeah, exactly. There's actually two different elements that are represented in a water molecule. And what we mean by that, remember this thing? The periodic table of elements. These are all like the 120 known naturally occurring elements on our Earth. So Emma knew that different colors on her model represented different elements. Okay, well, with that knowledge, if there's two different elements, why did you use three gumdrops?
Oh gosh.
She's totally on the spot.
Because there's two different
Two different elements, you're right.
three different atoms.
Well, is it three different atoms?
Oh, two that are the same, but one's different.
Whew, I totally put her on the spot. We did not practice. Okay, that's the life of being a Johnson. So take a guess. Why are two of them white? Why did you make those two bottom ones white?
Because in the H2O formula, there's two hydrogens.
There you go. So it must be that the two white ones on this model and the two white ones on Emma's model, and whatever the two were on the bottom of your model, those represent the hydrogen in an H2O. And therefore, then the red one represents your oxygen. All right, the next one Emma's going to build. Ready? Get started, kiddo. She is now going to be drawing a carbon dioxide molecule. Now keep in mind, the atom is the little tiny smallest particle that we find on Earth, and that particle has protons, electrons, neutrons. Are you guys all watching her make her molecule back there? She put two toothpicks through her gumdrop. So each atom has protons, neutrons, and electrons. The number of protons determines what element it's going to be on the periodic table. And then when we combine those elements, we end up with a molecule. Let's take a look at Emma's lovely carbon dioxide molecule. Dun, dun, dun. There it is. All right. Why did you use two different colors?
Because there's two different elements.
Yeah, there's two different types of elements in this formula. There's carbon is one of the elements, oxygen is the other element. So taking a look at her model here, what color on yours represents the red oxygens on my drawn model? What color gumdrops? That's okay. What color of your gumdrops?
Green.
Yeah. So Emma's green gumdrops represent the two oxygens up here. It doesn't matter what color you used as long as these two are the same color. And then your purple one represents the oxygen. Now there's something different. Well, there's a couple things different between these two. Besides being different elements and using different colors, what else do you see that's different about them, Em?
It's double bonded, so it has a stronger bond.
Yeah, so she's taking a look at the carbon dioxides here, and she saw in the model, in the picture, that there were two lines, and those lines represent the bonds holding the elements or atoms together. She's making a prediction that the two lines represents a double bond or a stronger bond. So it's probably harder to rip this oxygen off than it is to rip off this hydrogen from the H2O water molecule. You're right. Okay, I'm really putting her on the spot because we didn't practice this next thing at all. Lots of people have heard of carbon monoxide. You built a carbon dioxide, di meaning two. Carbon monoxide is a colorless, odorless gas that kills people. Well, kills all animals, okay? We know it's not a good thing. It is a byproduct of combustion. So if you have a gas heater in your house or gas cooktop, wood burning stoves in your house, sometimes if they're not properly vented, they can pump carbon monoxide into your house. Make a prediction. What should this model look like if it's a carbon monoxide? Model meaning one.
There's only one toothpick.
So do you think the monoxide,
Or does it have three of the same? Oh, one oxygen. I totally knew that.
That's okay. That's why we're doing this. So carbon monoxide. So rip off one of those oxygens.
That's a green one.
Yep. There we go. This would be a model of carbon monoxide. And it does not like floating around like this. It's much happier when it's got that additional carbon. I'm sorry, when it's got that additional oxygen bonded to it. So in your body, if you breathe this carbon monoxide in, guess what it's going to steal from your blood? So this does not like floating around like this.
Yeah.
Okay. It's much happier if it's got two oxygens with it. So if you were to breathe this in, not the gumdrop model, but I'm talking about real carbon monoxide, what is it going to steal from your blood?
Oxygen?
Yeah, not a green gumdrop from your blood. Instead, it's going to steal oxygen from your blood.
So that's why it like kills
things
because it takes away the oxygen that you need.
Exactly. Now, if you were to talk to a biology teacher, they would go into a much more thorough explanation about your something with the hemoglobin and how it replaces and disrupts but the gist of it is that it robs your body's oxygen of the oxygen that your cells need. Okay, so it doesn't allow that oxygen to supply your body to get around in your body. Okay, putting them on the spot again.
Oh, man.
Oh, so this is more than one molecule bonded together. And you guys got this little paper home with your gumdrops. We're going to give Emma a minute to work on building this thing. Okay? You ready, Emmy? She's like, no. She's got this whole container full of gumdrops. So build us a model, Em. Okay, Emma's working away on this over here on her project. While she's doing that, let's quickly look at this PowerPoint. She made the water molecule, she made the carbon dioxide, and right now she's putting together the 4 water molecule. let's take a little look at this model she's making right now. Look at those two hydrogens attached to an oxygen. It's just like the first water molecule that she made, except this model shows the hydrogens much closer to the oxygen. You don't really see the bonds between them. Instead, they're showing you this dashed bond that holds this water molecule to this water molecule. So we'll see what she comes up with. So taking a look, here was our atom with its nucleus, protons, neutrons in the center, electrons on the outer edge. We had an element, and the number of protons, 6 protons, tells us that it's a carbon atom. And our molecule is taking something like a carbon atom and an oxygen atom and bonding them together. In this case, we had 1 carbon and 2 oxygens. Whole thing is we are using this periodic table of elements. Ooh, let's take a look at how she's doing on the spot. There it is. There it is. Oh, that's good, just like that, Emmy. So let's take a look at it. Oh, she's almost done. Okay, she's got it done. Hold this thing up, Emma. There's her model. Does it look like this one? Yes, it does. Yes, it does. Now let's talk a little bit, and don't go anywhere with that model. And this particular one showed some dotted lines in between this water molecule and that water molecule. What did you use to connect 2 different water molecules? Ooh, it's probably weaker. So you got to hang on to your molecule here. You hang on to that water molecule and that water molecule and open up that bond. You hold that. Okay. If this was liquid water, okay, and you dive into the water and you go swimming through that water, you can easily break those bonds between the water molecules so that you can pass through. But once you've passed through, bloop, they reattach themselves. There we go, they magically reattach themselves. So we say that water molecules are sticky because water sticks to you even after you shower. You try and brush it off. It continues to stick to you. All right, Em, you're a good sport here. Don't go too far, okay? So that was really like last week's lesson, but you're going to be wrapping it up this week. The other little thing I want to add in this week is periodic table of elements. Okay, these elements that are found on Earth, we consider these naturally occurring. Would you say a gumdrop is naturally occurring? Says, yeah, we have a gumdrop tree out back in our yard. Wouldn't it be nice? Imagine having like a candy bar tree. That'd be really good. It doesn't have to, okay? Those are not naturally occurring things. Instead, those are man-made, although we really should call it people-made, okay? They are synthesized or synthetic products that were created by us. But what is it made of? It's made of elements from the periodic table. So, chemical formula of a gumdrop, well, there's your extra credit this week, guys. You need to go online and look up the chemical formula of gumdrops or gummy worms, something that's squishy and yummy and full of sugar like this. Email me that formula for a gumdrop or a gummy worm, and that's your extra credit for this week. Last week, the people who did the extra credit, I mailed them a candy bar. Okay? So Emma's going to make something for us that people were making tons of this stuff. So Emma's going to go grab some supplies. And you remember slime? Maybe you guys still make slime. I don't know. Slime was everywhere about 3 years ago. Everybody was making slime. It was in my carpet, on my couch, all over the counter all the time. So bring over this. There we go, so that they can actually see the supplies. Your fingers. So, one of the many ways to make slime is using glitter glue. Okay, using some Elmer's glue. And the other stuff we used was Tide liquid detergent. Okay, while Emma goes ahead and mixes those supplies together to start to make slime, we're going to take a little look at the chemical formula of that. Yeah, you can use whatever you want. So I went and I looked up online, okay, the chemical formula for the primary ingredients in Elmer's glue. Not a super exciting slide, but let's look at it. Elmer's glue is polymerized form. It is a polymerized form of CH2, CHO2, CCH3, or a polyvinyl acetate. That's what Elmer's glue is. It's a polyvinyl acetate. That is not a naturally occurring substance. However, the elements bonded together make molecules come off of the periodic table. So natural elements create synthetic material. That's what I need you to walk away understanding from this week. So what we're combining that Elmer's glue with, oh, I thought this was funny. I had to put it on there. Elmer's glue also contains proprietary chemicals about which the company does not disclose the details. That's their secret ingredient to make Elmer's glue so wonderful. So the other thing, the laundry soap, check out this long chain right here. This is a massive molecule. And there's lots of C's, which are carbons, lots of H's, which are hydrogen, and the numbers behind them tell you how many. We're going to go all the way to the end of the chain, and there's a COON and then a lowercase a. And that capital N, lowercase a, Na is the element sodium. So there's actually a sodium with all these carbons, hydrogens, and oxygens to make up our laundry soap. We mix these things together, and let's see what MJ's got here. Let's see it. Woo, there's some slime. That's not what I'm going to send you as your extra credit. That would be awful. Yay, I'm so excited. She's going to be a scientist just like the rest of the people in her family. So slime is synthetic material made from these natural elements found on the periodic table. So this week, guys, I will see you at the live Zoom at 9 o'clock, which we're going to kind of just talk about this stuff again quickly. My live Zoom will only be about 15 or 20 minutes. I'll be back for my office hours on Tuesday. Wednesday, there's no school. Thursday and Friday will be in session. The following week, we're going to have an assessment. So on my class pages this week, you're finishing your molecules and sending me the pictures with the questions answered. And then the other thing you're going to do is you're going to practice about 15 questions on my class page. I'll probably put them together in either a GIM kit or maybe in a Quizlet, but something so that you can practice it in preparation for the following week. So it'll be an assessment, a 10-week assessment test. All right, have a great week and pop into my office hours. There it is.